Okay, here's another question where the word uniform comes up, and I like to understand how we work, with a question when he asks us to check if a distribution is uniform or not. A researcher claims that the number of different color candies in bags of dark chocolate M&Ms is uniformly distributed. Uniform means all the colors are the same number of colors, like brown, yellow, red, blue, orange, green, and this are exactly the same color. So if you buy a bag, you should expect, let's say it has 60 candies, you should expect to see 10 brown, 10 yellow, 10 red, 10 blue, 10 orange, 10 green. That's what uniform means. To test this claim, you randomly select a bag that contains 500 dark chocolate M&Ms. That's the sample size. The results are shown in the table. So we purchased a bag that has 500 candies, and we found out that 80 of those were brown, 95 were yellow, 88 were red, 83 were blue, 76 were orange, 78 were green. Using alpha equal 10%, perform a chi-square goodness of fit test to test the claimed or expected distribution. What can you conclude? So here's how we state the null and the alternative hypothesis. The null will be the distribution of the number of candies in each bag, the colored candy in each bag is as expected or as claimed, as I mentioned in different examples. But since he uses the word uniform, just use the word uniform here. So you say is uniform, and that's the claim, because he says this is the claim that the number is uniform. HA will be the complement. So the distribution of the number of different color candies in a bag of dark chocolate. Sorry, we change this one. Of dark chocolate M&Ms is not uniform. Sorry, I wanted to put is not uniform here. Oops. Right here. Okay. So is not uniform. All right. So here's how we're gonna do it. The frequencies, as I explained in a different example, are the observed values. So the ones that I circle in red are the O's, the observed values, and we need the expected frequencies. As you notice here, he didn't give you a percent of each color, but he gave you a hint. He says the colors are uniform. That means the expected, just frequencies, that all the colors should be the same. So if you have 500 candies and you have 6 categories and you expect, just each category to have the same number of candies. So in order to find the expected values, all you need guys to do is divide 500 by 6. Why 6? Because I have 1, 2, 3, 4, 5, 6. 500 divided by 6 will be 83.33. So 83.33 will be the expected value for brown, the expected value for yellow, the expected value for red, the expected value for blue, for orange, and for green. And let me show you how we're going to put that in StatCrunch. Okay, so I input the observed values right here. I change the name of the variable to observe. I change the name. Just click on it and change the name. As simple as that. Look, you can change the name here. Expected. And as you notice, 83.33, 83. So if you multiply 83.33 by 6, you should get 500 again. Okay, and then we go to stat, goodness of fit test, chi-square test. It's a very easy test to perform. Observed, expected, and that's it. Hit compute, and let me show you the test statistic. So the test statistic here is 3.016. It's a small. So the p-value is going to be large. 0.6975, which is bigger than alpha. You're going to fail to reject the null hypothesis. So let's write this down. So the test statistic is 3.016. The p-value is 0.6975, which is bigger than alpha. So we fail to reject the null hypothesis. And we fail to reject the null hypothesis And the claim is the null hypothesis. So then we fail to reject the claim. We cannot reject the claim. That means the manufacturer claim is probably valid. So we say there is not enough evidence at the 10% level of significance to reject the claim that the distribution of the different number colored candies in a dark chocolate bag is uniform. So when you don't reject the claim, that means probably the claim is accurate, is correct. Okay.